Hi, this panel basically is about finding the on-ramp. How do I get started in HPC and enterprise? And the panel's going to introduce themselves, but just briefly, Tim Cowles on the far right, Merle Giles, Susie, and Wolfgang. So, guys, you can spend 1 minute max. Just introduce yourselves.
So, my name is Tim Carroll, and I'm with Cycle Computing, and we are not an HPC in the cloud company. We're actually a company for people with problems and deadlines to solving those problems. And what we do is help them solve them.
Great.
I'll top that.
Boy, that was short.
Well, a minute or less. Come on, do it quicker.
We are an HPC organization. NCSA, the National Center for Supercomputing Applications at the University of Illinois, that's in Corn County, Illinois, otherwise known as Champaign. And what I run is our private sector program side of that. So I just had a gentleman here ask me a question about what we do with academic and codes and other side. No, we don't play with that at all. All we do on the private sector side is help guys like Todd Simons and others in the room here do what they do better. We've got big computing, dedicated computing, expertise, and all of that needs to come together in the room at the same time, typically, to be able to move the dial. So we help companies do that.
I'm Susie Titchener. I'm Director for the Industrial Partnership Program for the Computing and Computational Sciences Directorate down at Oak Ridge National Laboratory. If you're not familiar with the lab, we're down in a suburb of Knoxville, Tennessee, in East Tennessee, and we're DOE's largest science and energy lab. And we also are the home of the Department of Energy's most powerful supercomputer in an open environment, meaning not classified. We obviously don't know or talk about what's in the black world, but for unclassified scientific computation, we've got the nation's largest supercomputer, and I think we're still number 2 on the top 500. But it's not just about having a big computer. For us and for our industrial partnership program, it's about helping companies solve big problems. And you don't need to necessarily be able to use the full capacity of our system. It's a big one. It's 27 petaflops. But what we want to do is make time available and our expertise available at our center to help companies solve problems that are greater than what they can do internally with their own resources, but which, if they could make progress on them, would help them to make a real competitive leap. So when I say we look for high-impact science and engineering and math problems, that means high impact to the company. It means something that's really going to help propel them forward. We're agnostic as to whether or not a company is large, medium, or small. We have large companies that work with us, and we have startups that work with us, companies you've never heard of, but who are doing very exciting things. And making sure that they get access to the computational resources that they need has really helped them solidify their firms and accelerate their ability to get new products out to market. And that's what we're excited to do.
Thank you.
Yeah, nice. So my name is Wolfgang Gensch. 30 years in HPC, about that. Living through vector, parallel, distributed, grid, and finally cloud computing. First third about researcher, second third educator, and third industry, basically. So now finally ending up in the Uber cloud. Having lived through all that, 30 years feeling the pain of the end users. I was an end user for a long time myself, and always trying to help improve, etc. But as you know, nothing really moved from the end user point of view. So finally we consider cloud to prepare the breakthrough which takes us to democratization of HPC. And I will talk a little bit later about especially that one. But for now, that should be sufficient. The Uber Cloud is now 3 years old, and we are still in a startup mode. First, talking to a lot of especially end users and their providers to really find out their pain in real concrete. I mean, not in these high-level hype buzzwords, but what they really care about. And then we believe we found I wouldn't say the holy grail, I love that word, but it's, I mean, we use containers like we have heard it in the past couple of days, which are a real breakthrough for what we intend to do. We further develop these containers into real HPC containers. So you needed to do a lot of things to do for getting from microservices to so-called macroservices. So that should be enough for now.
Thanks, Wolfgang.
Yeah.
What Wolfgang didn't say is that Uber Cloud's just been nominated by Gartner Research as one of the cool companies in IT for oil and gas. Great stuff, Wolfgang. Over the last couple of days, we've heard a number of companies talk about their journey into high-performance computing in the enterprise at completely different journeys. Drilling Info clearly went through huge internal changes, both in software and approach and people. Some of those changes very difficult to actually do. A philosophy, it seems, very much like sort of fail often and fail fast has helped them get to where they are. Then we heard from PayPal, very different company. It's an $8 billion company. There's two guys taking advanced high-performance techniques to run their operations. And they even talked about MPP and using accelerators. Don't often hear that in the enterprise organizations. Then Gulfstream yesterday and their journey to recognize that the company Gulfstream, much like Rolls-Royce in many ways, a different scale of course, but seeing the benefits of high-performance computing, designing better products, faster time frames, faster time to market to be more competitive. And that's really what the on-ramp, I think, is how do you get started in this mode? And I've got a couple of questions for the panel, and then I think I want everybody to sort of ask questions. First question really ends sort of where yesterday ended. It's really aimed towards you, Merle, and you, Susie, is about you both have programs which help commercial companies access high-performance computing. But how do they actually get about getting engaged in that? What did he do?
You want to start first?
Go ahead.
Okay. Well, there are multiple ways. First, just pick up the phone and call us, and let's talk. We want to hear about what your interests are. We want to hear about what your problems are, and what you think you need, and what your goals are. In the DOE system, and by the way, as I mentioned yesterday, we're part of a family of laboratories that have supercomputer centers, and we operate similarly, although not identically, and so it's important to know it's not just Oak Ridge, although I would love to have your projects come at our center. We love working with you, but as I mentioned, there's Lawrence Berkeley National Laboratory and the Office of Science Family, and David Martin's here from Argonne. We all have, we participate in different programs through which people can apply for access, and those programs depend really on how much time you need, how well your software scales right now, how long you think your research project's going to last. So problems can range from 6 months to 3 years maybe, you know, where you're granted time on a yearly basis with renewables. And so I think we have a menu of options depending on what your needs are. And I can go into those now. I don't know that it's of interest to everyone, but I think that it's suffice to say that we have this menu and we will walk you through it and try to right size what your needs are to some of these different program areas so that you're slotted in appropriately and can get the access that you need. So we try to put these programs together to meet different needs and different time frames.
All right. Merle?
So NCSA sits inside the University of Illinois and sometimes acts like a university center, but that academic side tends to be in an allocation manner because the big computer we have is funded by the NSF. So again, open science and engineering, like Susie works with at her site with the DOE. But there's another way, and the way we engage with companies is more on a pay-as-you-go method. We try to partner. What we've learned over the years is that to just try to do cycle provisioning is inadequate, because in order to change behavior, we actually need a dialogue about the workflow, the things that Todd Simons talked about, the on-ramp specifically in manufacturing comes out of CAE codes and so forth, the model building. And then HPC does the simulations. So we try to pay attention to the workflow. We help companies manage that. We do this in ways that include contract consulting. We do it in ways that include a partner model where there's some overhead so we don't have to nickel and dime everybody. But really it is a close engagement on how to begin to change behavior. So HPC is the reason we have those dialogues, but we talk about more than HPC in the process. It includes other data. So it's very direct, hands-on work with companies.
Is there an upfront fee for this, or is it pay as you go, or how does that work?
Just chatted with one of the manufacturers in the room here this morning, is that, yes, we want the fee, we want to treat that as overhead so that we can not have to act like a lawyer firm and nickel and dime every time a phone call happens. But so yes, that is a partner model. Fees are involved, but one of the things that we can do early is benchmark how to do things so that a company can actually know what's possible on very modern hardware and begin to see whether they should improve their own systems or whether they should use ours or how to buy and deploy on their own.
Good. All right, great. My second main question now is aimed really towards Tim and Wolfgang, and it's really about high-performance computing and the cloud. Lots of discussion about the cloud. Lots of people are using it. A lot of people, of course, using it for things like ERP and traditional Office 360 and all those kinds of things. But is a cloud good for high-performance computing?
You have the mic.
Okay. Yes. So, but here's the answer is yes, but you'll never know until you try it, right? And one of the great things about cloud is it gives you the ability to turn it on when you need it and turn it off when you don't. And in a previous life, I ran a business where if a customer wanted to test something out, we had to send in test nodes, and there was a lot of upfront work that went into even validating whether or not this was something viable to go chase. And I think that the recurring theme from very successful companies over the last, since the time that we've been here, is whether you want to call it fail fast, whether you want to, whatever those things are, the best way to figure that answer out is to do it for yourself. Now, at an aggregate level, we sat in front of almost 440 million compute hours last year across financial services, pharma, and manufacturing. So there are a lot of people who are doing a lot of business critical work, but what they're focused on when you ask them is that they're solving problems, that HPC very rarely works its way into the conversation. So the answer is, if you need the proof points in order to get the pilot started, we can help you, we can provide you with some proof points because we've got production customers that run back for us 5-6 years. But then after that, it's very easy to get yourself up and started and start learning what you don't know, because that's where it really accelerates, and then you can figure out what the real value is going to be relative to the specific problem that you're trying to go solve.
Okay. Okay.
Another yes, but so we have this slogan: discover, try, buy. With any new technology, with any new service, and you want to get somehow into it and on-ramp, onboarding or whatever. And for an engineer in any company, small, medium, large enterprises, it's always the same, which cloud provider is best suited for me? Very difficult. I mean, you are busy. You don't have any clue about the 54 cloud providers we are working with, for example. So you want to give them some guidelines. And 3 years ago, we started with experiments. So we took end users who are interested and who are already working in HPC, or in desktop HPC, most of them, definitely. But it's a little parallel computer which already sits on your desk. So we took their applications, throw them over into the cloud, and studied this process, helping the end user to better understand this end-to-end process, and also basically finding their specific benefits. Everybody gets something else out of the cloud, right? And finding their sweet spot benefits, and then going to the management and saying, okay, we need that. So there is a similar approach which is not at all different from any other fresh new contact with fresh new technology. And when you have done that, finally cloud is good for HPC. Okay. Because a cloud well done, and I will talk about that a little bit later, so cloud well done will help to get to the better, faster, cheaper benefits easier. So that's the access itself is a hard part today to get into the
So it
cloud.
sounds like it's both easy to use the cloud and it's easy to get engaged with the academia DOE labs for expertise. So that's
Well,
good.
we hope it is.
Oh, that's true.
We're trying.
I mean, we are all trying to make it easier.
Right, that's good.
Steve, this panel is pretty unique, so I applaud you for putting it together, but each of us actually does that. Excuse me. I should have brought coffee. It actually does that engagement with folks directly. So the cloud side, absolutely. The big HPC, we need a front person to be able to help with all that. And absolutely,
champion type
it helps a
approach.
lot.
A champion.
And a champion, sure.
Yeah, I think that certainly came out when we're listening to the end users up here, the panel and presentations. Having an internal champion most definitely is something that's really needed. Okay, let's have questions now from the audience. Where's Phil with the microphone when you need him? Okay, Tom?
Not close enough. Over the last 4 events. Over the last
Athletic powers.
Yeah, right. Thanks, Wolfgang. Over the last 4 events that we've done, some of the prevailing questions have been around, the how do we get started, and specifically the needs analysis process. So, because you got to do that before you can begin the proof of concept, and you get into the performance and acquisition and integration and so on. But so, I was just wondering if you could share with us, a little bit more detail, what's involved in a needs analysis.
Yeah. So, relative to the workloads that we work with, one common theme amongst all of our customers over time is that I can't think of a single one with whom we worked to do HPC in the cloud for the sake of HPC in the cloud. It was always driven by a workload that they either needed to run and did not have enough internal capacity to run it, or because they realized that the computational and data storage and management requirements on their internal infrastructure were going to outpace either the budgets or the 4 walls of the data center that they had, and they needed to start figuring out how to offload applications that shouldn't be running on that expensive specialized system to begin with and run them in a more cost-effective place. In both of those cases, the entire conversation that we were able to have was centered around a business problem that we were solving, and that was what kept us out of getting hung up in the philosophical, religious, political, whatever other conversations around cloud and what cloud and all the other pieces related to it. And so it's a bit of a broken record to keep pounding on, have an actual problem to solve, but it's the easiest way to get through how do you get started. Because the way to get started is the line of business owner who's back there tapping their foot saying, when am I getting an answer, or at least pointing in the direction of an answer.
Okay. Anybody else add to that? Yeah, I think needs assessment, needs analysis are really critical. Got to know what you're doing before you actually start. Then you can measure your success at the end of it.
Starting with the business problem absolutely is the best sense. We tend to deal mostly with companies that already do some amount of modeling and simulation. The smaller companies will do less. The big companies, we can even help. So even in the Fortune 30, the legacy behavior in the companies has often been around what they had available, and they might have deployed HPC. And we also see that classically the emphasis on HPC has been very CPU driven. Can I get more CPU to get more stuff done? And it turns out in an excellent system earlier about using parallel file systems, well, yeah, that matters. It really, really matters, especially in the CAE code base. So how do you know whether you could do it any better? Well, you don't, unless you can reach out. So one of the things we do is take the existing simulations that are being done with the company and try to show what might be possible and just build a curve. We have academic licenses where we get to do this on a wide variety of well-known CAE codes, for instance, and we can show a curve. What is possible? Where could you go with this? And then we can...
So you profile the existing execution.
Absolutely, we'll
so
profile.
IO bottleneck, CPU, whatever.
Best case in a small company that's working on 4 or 8 cores, take an existing input deck, go run it on modern hardware, and boom, we're at 192 cores instead of 8, and the 3-day job just became 3 hours.
Yeah.
That's just dirt easy. I mean, but now you've got to decide, do I want to buy that routinely and turn that into a lifestyle, or do I really want to do that? Well, you can't not answer the question until you see what is possible.
Yeah. Okay. Good. Another question, I think. Arden, sure.
Can any of you comment, I guess I'm in manufacturing space, similar to some other places here, and we don't develop code, we rely on software vendors that have commercial applications. So can you comment on software vendors' approaches to computing in the cloud? My personal experience is that that's one of the things holding my company back from pursuing cloud as aggressively. The hardware's there, the software is there in terms of the interfaces and job schedulers and things like that, but the actual solver, it's a big deal when there's tremendously high cost associated with going to the cloud. I'd love to be able to burst up to thousands of cores, but I don't have a way to do that for a week or a month. I generally have to sign up to a quarter or a year's worth of licenses that I maybe don't need for that whole year.
Right, so it's a combination of does the code scale, and if it does scale, the ISV licensing can be restrictive.
Correct.
It stops you
So,
really
so what's
using-
your guys' observations on that or comments there? We've certainly seen demonstration when we partner with the vendors that the code scale. So all the stuff of it's good enough or what can it do,
Yeah.
we see when we go calculate our ROI, cloud fits outside of what we'll pursue, and currently, moderate scale stuff on our internal systems does fit for
Yeah.
ROI.
Yeah. Certainly that's been a hot topic in the industry since it went somewhat multi-core, multi-threaded and so on. So it's a really,
Yeah.
good, really good question, yeah.
Yeah, so 3-4 years ago, it was really almost impossible
Yeah.
to get a short-term license in the cloud because ISVs were very concerned about disrupting their own customer base, right? Thinking they were all moving now to the cloud and it's all just, instead of 1 year, it is 1 day or so. It turned out not to be. Most of the licensees are still sitting on simple desktop systems. And there is no way for many of these to get easily like bought an own supercomputer. Or, 3 years ago, 4 years ago, it was more difficult to work with supercomputer centers. The way we see it here now, almost standard. So it was really within the last 3 years that ISVs turned completely around. We saw this great announcement from ANSYS just last week, announcing the ANSYS Enterprise Cloud. Right? So now, there are some exceptions. CD at UPCO with Star CCM Plus, they had this token-based model for almost 10 years, and it turned out that this is beautifully done also and including the cloud. You go, you buy your 40 tokens, you go to the cloud, you type in a keyword and your license number, and then whoosh, you run. And the additional beauty is that especially this software is independent from the number of cores you are using. So this is ideal. Very similar console, multiphysics. But on the other side, we have these good old conservative guys who still had the idea. ANSYS had the idea. They are working with us for 3 years now. So they had the idea. We did 15 experiments with ANSYS, by the way, in the cloud. So they had the idea 3 years ago, but within ANSYS, it takes 3 years to get something like that, almost disruptive, done. And just last week on HPC Wire, they announced that. So this is one of the big breakthroughs, because now everybody is looking at, ANSYS is doing it, 20% of the CAE market, right? So expect basically that licensing in the cloud, the challenge around this will completely disappear within the next 2 years.
That's certainly be a great thing to see.
Arden, I'd just like to add that we have seen in every instance that if you bring a challenge to run with an ISV that you already buy from, they have been bent over backwards to try to work with something on our systems, for instance, because they know you're a valued client long term, And in a one-off way, we've been able to work with ISVs to do something at our place that actually provides you that flexibility to do something on a shorter-term basis.
So demonstration-wise, I know that most of them will cooperate with no issue.
But
For my planning purposes, I see an absence of a high-value licensing model. Keeping that goal great. To me, they're the number one of the vendors I work with. The recent announcement from Kansas, I need to see the details of that, but in spirit it sounds good.
in spirit it does, but
are missing that.
your observation is so right, Arden, and one of the problems that the ISV community has had over the years in actually building that model is their own persistent access to HPC for clients. If we look at the academic institutions, universities, they don't know how to serve necessarily a customer like you. They're just not set up, and they may not even deal with commercial licenses on their own equipment. So the places to do that are pretty few. We got a couple up here. There aren't so many more, but they are out there, and that has increased some in the last few years as well. But for them to build the model, they also need persistent access to HPC, and a few of us are beginning to see some changes there.
It certainly is a really hot topic, and it certainly is clear that the industry needs to change to accommodate this, no question. Maybe ANSYS is the first of hopefully many. Hopefully, Wolfgang, you're right in that kind of prediction. But it is a handicap, and I think about Todd's presentation at Rolls-Royce. Someone asked a question about why do you use your own code sometimes. It's financial reasons that are driving them to keep doing that.
Steve, let me just echo what Merle was saying, that at our center, as I mentioned the other day, we're considered a national user facility. So the Department of Energy does not purchase commercial licenses for our center because many of the customers, the users coming, are using open code or bringing their own. However, we have not, just as Merle said, we have not experienced any challenges with the ISVs. When a company wants to come and use their software, they allow them to bring the licenses and generally just say, go at it, use as much as you want. And we load the software up, we don't have a problem with it, and we encourage companies and ISVs, in fact, to partner together and come so that they can both work on a project. I know that doesn't necessarily help your long-term planning from a corporate perspective, but it should allay any fears about could I actually execute with that ISV software down at a national lab center.
Like our company, we've been waltzing with
Right, that's
on-demand or cloud computing for about 3 years. We've seen the benefit of it, but it could be for us, but the cost is too high. Initially there were some issues maybe with the virtualization, being able to do data transfer, but I think the industry's worked through that, or at least we've found better solutions there. The issue comes into just scaling and quality.
I think the best advice is go back to your ISV providers and just continually pound on their desk to demand changes.
They certainly heard from me.
Yeah, well, keep it up. Keep it up. Another question, please, in the back here.
Yeah.
So I caught this a little.
Got to auction it off next.
Someone handed me the microphone. So I caught this a little back in your discussions. One of you mentioned that in your discussions with customers and their workflows, HPC often did not even come up or came up rarely. And my question really is, do any of you understand why that's true? And a second question that maybe I could direct to Tabor is, why at this conference are there not represented more chief financial officers? Because if the result of the first question is what I think it is, you've got to get the CFOs on board with this. So, thanks.
It's a good question.
I can answer that question.
And that's something we certainly can think about for next time. This deal with the both IT and also CFOs. It is a financial issue, no question. Another question.
Changing the topic slightly. This panel is really, really interesting as a singular panel, in that each of you represents a different way of getting to compute resources. Quite different, in fact, right? We've got cloud enablement from Cycle. We've got public business partnerships with a major supercomputing center from NCSA. We've got public-private partnerships going on, through FFRDC stuff, and we've got cloud brokerage going on, right? So this is very confusing to people who aren't really involved in really understanding where resources are and how to get to resource and what resources are the best and what works well for us, right? In our lives at BioTeam, you know, we find ourselves blending these a lot. So I'd be really interested to hear from all of you about, you know, why is yours the best? Or what's it best for? What are the use cases? And then, you know, is there some, you know, what advice do you have for people who are trying to seek out computational resources?
Well, there's a lot in that question.
Well, I'm sure we'll all
Susie's
start.
got
Why don't I
the mic,
just
yeah.
start? I
You got the microphone, Susie. Quickly, yeah.
Where are we the best? Okay. First off, I would say where we're not good, and that should eliminate a lot of questions. I often tell companies, we're not the best place to come if you need an answer every Monday morning. Or if you're just running out of cycles and you need some surge capacity. That's not really what we're set up for. And if we get those kinds of inquiries, I always try to direct them to other centers who can take care of that. So if you're thinking about a longer term project, 6 to 12 months, we're a good place to come for that. If you have a problem that exceeds what your internal capabilities are, or you need access to expertise to collaborate, for help on scaling your workload, or getting access to domain scientists who may be able to help you to develop new algorithms or rethink a problem. National labs are a great place for that. And so I understand your frustration. It would be nice to go to a website with a matrix on there and say, if you're interested in this, go here. If you're interested in that, go there. That doesn't exist exactly, but hopefully, at least when we're talking with companies, we try to tease that out and make sure that what you want to do is that we'll be able to provide a good experience for you and help you get to where you want to go. And if we don't think we're the best center or the best fit, we'll direct you elsewhere. We'll direct you to an NSF center. We'll direct you to commercial opportunities that a company may not know about. I don't know if that helps, but.
Ari, let me answer you another way. I think what you see here is a spectrum and a continuum from research all the way up to production. So really, the early cloud access for a lot of folks who are exploring, Wolfgang's got the best business model on the planet. Absolutely the best. Bigger cloud, don't know what we can get done. This guy can help that happen. I've got big production computing. She's got very big scientific research computing. So it depends on what you want to accomplish. And as you work from early work to more R&D, you get beyond R&D and need to do production, the places to go actually vary.
It's a Wolfgang, do you actually pay more for that endorsement?
I don't tell you.
Okay.
In terms of the best place to go, I think that ultimately what's going to happen, and Don Burr, I'm not sure if he's still here, was pointing out yesterday, the number of people who are here at this conference who are still from either the engineering or the research side and not from IT. I think that the role that is going to develop within corporations is that there's going to need to be a seat of expertise that does exactly what it is that you're talking about. And in the interim, it's going to be fulfilled by consultants, and I think it's going to be a hodgepodge for the next 2 years or so, since the industry is still in its nascent phases, right? And so you're really going to have to go to the trusted agents, but I would say that for organizations, it's going to be critical that you don't outsource that logic, right? That's the one thing that you're going to want to have that's all your own, is figuring out where is the best place to go get the proper resources. You know, when PayPal was presenting yesterday, they were talking about the data that they were collecting, but they're not yet acting on that data automatically, right? There's still a human check in the process. We get the same thing where people are like, oh, we want to burst to cloud automatically once the system's full. And I'm like, no, you don't. Not if you want to have to pay the bill at the end of the month when it comes, right? There's still pieces of this that need human intervention. So, you know, if you're starting to head down this path and you're looking at it, I mean, I would get external expertise in to help you out, but ultimately, you're going to be the ones that have to own that, that decision, because this industry, what we're doing right now, is going to be so fluid for the next 3-4 years. You know, I ran a big infrastructure business for a long time before I joined Cycle. And I'll just tell you that the industry itself, the infrastructure that will be supplied, is in for an interesting run over the next 5 years or so. And there's going to be a lot of change and a lot of fluidity in terms of who's in, who's out, who's up, who's down, and who's got the right people and who's got the ability to solve the problem. And so you're just going to need to be prepared for that as you're making your own decisions.
Wolfgang, anything to add?
Yeah, so adding, I want to pay it back. I mean, this was a great summary of the service spectrum we face. And it is, I mean, it is almost straightforward. I think it was not a complicated question. So there are these 20 million engineers and scientists out there. Merle cannot handle them, Susie cannot handle them. So I'm talking about the long tail, especially. I mean, these guys are really up to the 2,000 globals, so the global 2,000 in this order. So there are all the others who are looking for something, you know, for a solution which they can get every Monday morning. Like, so they go to something, click on it, and they are immediately connected to the cloud, and they work in it. They have short-term peaks, they have short-term deadlines. All that stuff is not really suitable, for example, for this business model, right? Yeah, I would leave it like that, because
right.
I will add something.
Thank you. I think we have time for one more question.
Hi, thank you. So I've spoken to a couple of you, and I think, Tim, we mentioned it yesterday during our session. The compute or calculate as a service concept is what I'm really focused on here as it relates to this. I mentioned Mathematica and Wolfram Alpha, for example, is a very simple interface that I can feed in very, very basic questions that I can get back in a pretty responsive time cycle, some pretty good answers, right, and link to a much broader information source. I'd like to be able to do that with much more sophisticated questions of the kind I think that you're after, Wolfgang, and so on, and being able to provision. But where do you see that going from a software as a service paradigm that helps the enterprise to a compute or calculate as a service paradigm for the scientific and engineering community or the development community?
It's all going to come down to the business model, right? That the ISVs need to figure out a way to monetize that in a way that they don't have to add 50% overhead or 50% cost structure to figure out how to capture that revenue. And just to circle back on the ISV thing, I'm under non-disclosure to several of, I'll just call them the usual suspects. And I would say that having been dealing with most of them for years and years and thinking that the paradigm that we were describing earlier is not going to change, it's going to change. Because what's happening is that, you know, whether it's cloud or any of the other things we're talking about, we just as an economy and as a society are moving to pay per use. They want a unitized cost. And the ISVs understand that. It's just hard to move quickly. And so I think that we're going to have to crawl, walk, run. We're going to have to solve, how do we break this down into chunks where we can get it to a point where we're doing it on a per workload basis, where it's probably an annual subscription or something associated with it. And then once we've got that mastered, you can then get it down to a specific workload where it's all in one time. So that you can unitize that cost, you know, regardless of how big you are. So I think we're on that trajectory, but I think we're going to have to do it in steps, and that's probably step 4 or 5, and we're on step 2.
I would just add that in the manufacturing space, in the simulation space, with well-developed codes, I would agree with that ISV challenge, that has begun to change. But I detected in your question also an interest in data analytics that might be available in this cloud-like way. And that's a less mature market there. The kinds of data analytics machines are not as prevalent as classical HPC. So I think that business model will come as well. one of the things we've got to pay attention to, or is available in the cloud, is there's a lot of iron available, but the software base is not always up to speed. So the commercial codes are a good place to start with that. I think we've got a long ways to go in the next few years to do the same in the data analytics space.
Just to add to that, not only the commercial aspect, not only the aspects that our friend here brought up in terms of budgeting and scheduling and so on, but this idea that what and how to calculate something is core to some of the businesses, some of the ideas they're bringing forward. So how they place that into the cloud, or how they place that with a provision service, and keep that protected and yet bring that knowledge back to the core of the broader cloud, right? The broader calculation basis with unique content that makes them distinct.
Agreed.
Okay, I think they've, one last question, Tom.
It's
Better be last.
actually not a
Better be quick
question.
and-
It's
oh,
not a
quick.
question.
Okay.
It's more a comment. If you're interested in any aspect of, utilizing, deploying, whether, through an organization like either NCSA or Oak Ridge or any one of the national labs, or cloud, the members of this panel are quite distinguished. If you look at Tim's been in the industry for many, many years and was instrumental in installing one of the first Linux clusters, large Linux clusters ever, and then also ran the HPC division at Dell for a while. So, he has a lot of experience in first impressions of, how organizations can utilize the technology. Merle just wrote an excellent book on the sort of the history of utilizing HPC for a competitive advantage. Susie was at the Council of Competitiveness and was instrumental in some of the federal programs that are being sort of deployed today, that we're looking at utilizing these resources to increase the competitive advantages of HPC across many and multiple industries. And Wolfgang is the long distinguished career starting with BMW all the way through, all those distributed. They're being very modest, and he is the general chair of the International Supercomputing Conference Cloud meeting in Europe, which brings together all of the major practitioners of both HPC and cloud throughout, the EMEA space. So just wanted to point that out because it's quite a distinguished panel, from that regard, and thank you so much.
Okay, thank you very much indeed. Thank you, panelists.